The very first thing that we want to do for this binomial probability is to decide what a success is. So we've got 38% of undergraduates attended a community college at some point. We're going to sample 20 of them, and we want to know the probability that exactly 3 attended a community college. Now I'm also going to do at most 3 and at least 3, but exactly is a great place to start. So a success is going to be one of those students attending a community college. So let me write that down. So success is equal to, I'm just going to write CC for community college. We also want to know the probability of a success, and a probability of a success is lowercase p. That's going to be that 38%. I'm going to call that 0.38. Now, since this is binomial, you're either a success or a failure. So I can also define a failure here. If a success is attending community college, a failure is going to be not attending a community college. To figure out the probability of a failure, which we call Q, you're either one or the other. So I can go ahead and take 1 and subtract what I got for P. So that's going to be 1 minus 0.38. We end up with Q is equal to 0.62. Finally, we need to know the number of trials, and in this case, that's the number of undergrads that we interview. N, the number of trials, is equal to 20. So I've got all of my information, and I'm ready to put this into my formula. Now our probability was for exactly 3. So I'm going to write the probability of X, which is the number of students that say yes. So X is equal to exactly 3. So this means that we're going to have the probability of 3 that attended a community college, and 3, this is out of 20, so the rest, 17, did not attend a community college. That's going to give me 2 probabilities that I'm going to multiply together. So 3 attended a community college and translates to a multiplication. I'm really using that multiplication principle here. And I've got the probability of 17, I'm just going to say 17 not. As I put our probabilities together then, I'm going to have 3 of these community college probabilities. That's going to be our P, that's success, so 0.38. And I'm going to have 17 of those not, so to the 17, Q, and that's going to be a 0.62. But there's a problem with this setup, and the problem is that it assumes that my 3 students that say yes come first, and all the 17 after that say no. There's actually a ton of different ways that we could get 3 out of that 20. Not just the first 3, but we could get the last 3, or the middle 3, or 3 sprinkled in there. There are a lot of choices here. And to get those choices down, we're going to put a combination formula right in front. So right in front, I'm going to put that combination formula, and we want to take 20, and we're going to choose 3 of those 20 to be a success, multiplying that by our probability. So 0.38 to the number of successes, there were 3, and then 0.62 to the number of failures, there were 17. Now I want to put the formula up here so you can translate this into any of your scenarios. The formula looks like this. N, choose the number of successes. X is the number of successes. So it's N, choose X. And then it's P to the number of successes, but that's X, times Q to the number of failures. Well, if X is the number of successes, then the rest, so N minus X, is the number of failures. So N minus X. I think it's really helpful to remember that this is the number of successes, and this right here is the number of failures. Okay, well, we really just want to put this right into our calculator, and I'm going to show you 2 ways to do that. One's going to be just like you see it here, and the other one's going to use a distribution function in that calculator. Now I'm going to use my TI-84, and I do want to start with those parentheses, so just exactly like I see it. So I want parentheses, and then I'm going to put my n, which was 20. Now I'm going to look for that combination function, and I can find it in the math menu, so I click on math. Let's arrow over to probability, and there it is, arrow down to number 3, and then hit enter. So it's 20 choose what? I want 3 of those to be a success. Let's arrow over and put in another set of parentheses. Now I've got my successes. So I've got a probability of a success, which is 0.38. And I've got 3 of those, so to the third power. Let's arrow over for the failures. The probability of a failure is 0.62, parentheses, and that's going to be 17. So I've got 17 of those, so to the power of 17, and then enter, and we get 0.018, or about a 1.8% chance. But there's an easier way. Let's go find the binomial function in our calculator. It's a distribution, so it's going to be in our distribution menu right below those navigation keys. So I'm going to go second, followed by distribution. It turns out that it's towards the bottom of our list, so I'm going to arrow up, and I've got 2 different choices. A is for a single probability. This is for my exact case. B is for a cumulative probability where I'm adding up cases. This is going to be for my at most or at least case. So I want to choose Binomialpdf. Let's hit enter. Now, if your calculator looks a little bit different at this step and just says Binomialpdf, that's okay. The next screen is going to look exactly like mine. It's asking me for the number of trials, so I put in 20. It wants to know what the probability of a success, that was 0.38, and it wants to know my X value number of successes, those were 3. Now I hit paste. If your calculator just gave you that Binomialpdf, you're going to type in this order exactly. So 20, comma, and comma is right above the 7, P, which is 0.38, comma, and then your 3, we hit enter, and we get exactly the same value. This next one is an at most, but we've got the same setup. I just need to decide what I'm going to count as my X. So X is the number of successes, and at most means I'm going to have at most 3 successes, but 3 is the highest. So I could have had 2 students, or 1 student, or 0, saying that they went to a community college. Now I use that language or, and that is important because I'm looking at the probability that 0, or 1, or 2, or 3, which means I've got these cases, or means I'm going to add these probabilities together. So plus, plus, and plus. Each of these probabilities is going to have one of our binomial probability formulas. So it gets big pretty quick, but I'm going to show you an easier way to do it on that calculator. But I'm going to set up just at least part of this. So that first probability of 0 is going to be 20. I'm choosing 0 of them to be a success. So I've got 0.38. I've got 0 of them. You could actually just leave this off. And then I've got 0.62. All of them are failures to the 20th. I can do the probability of 1 next. So I would do plus the probability of 1. So that would be 20, choose 1, 0.38. Now one of them is a success. 0.62 out of the 20, that leaves 19 to be a failure. And then I've got 2 and 3. So now that I've got each of these written out, I can make sure that I've got everything aligned. I'm just going to look at the last one here and we can check this one. 3 is the number of successes, so 3 should show up on my probability of a success. And the 2 powers, 3 plus 17, should add up to the total number of students, and it does in this case. Now, I could put this in my calculator. I could, but I'm not going to because there is a much easier way, and that much easier way is binomial CDF. So I'm going to look for binomial C for cumulative CDF. We're still going to be putting in the number of trials. We're going to be putting in the probability of a success, and we're going to be putting in our X, but that X specifically means, since we've got cases, the calculator is treating x as 0 up to x. So x is the maximum number, so 0 up to x. For ours, we're going to put in 20, we're going to put in 0.38, just as we had done before, and we're going to put in 3, knowing that that means 0, 1, 2, or 3 in the cumulative distribution. So in my calculator, I want to go back to that distribution menu. So second distribution, I'm again going to arrow up, but I'm looking for that binomial CDF, and I'm going to choose that one. You could also think of C as cases, but it does mean cumulative. I'm going to hit enter. And again, if yours doesn't look like mine, that's okay. It's going to look like what I've got written there on the screen, but mine does give me these prompts. So I've got 20 trials, P is 0.38. It looks like the same screen, but the X value means 0 up to, and I want 0 up to 3. I'm going to go ahead and hit paste. So we're expecting a higher probability than we had before because we're adding in some, and that's exactly what we get. So we get a 2.4, about a 2.45% here. So I get 2.45%. Finally, we want to do a probability with at least 3. Now our setup is going to be the same, but at least 3 means that our favorable outcomes, the values that we want for x, at least 3. 3 is going to be our minimum this time, and it could be 3 students or 4 students or 5 students, all the way up to the number of students that I have, which is equal to 20. But the problem with that binomial CDF function is that they interpret x to be 0 up to a number. So I want to think of this on this continuum with all of our probabilities. So I've got down here, I've got 0 students, and up here I've got 20 students. I want 3 on. Those are going to be my favorable outcomes. So 3 on, let me go ahead and just kind of shade this in here. So 3 on, these are the ones that I want. What I don't want, remember x is a counter, I don't want 0, I don't want 1, whoops, I don't want 0, I don't want 1, and I don't want 2. If I have to use a 0 up to, I'm going to use 0 up to 2 as what I am getting rid of. And then I want to keep 3 through 20. Okay, so I want you to think of it this way. The probability of 0 to 2 plus the probability of 3 up to 20, those are all of the possible values that I can get. That probability is 100%. Or I can say that that's equal to 1. So when I'm figuring out my probability, I want to subtract what I don't want. So if I do just a little teeny tiny bit of algebra here, I've got that the probability of 3 to 20, I'm just going to write it this way, even though it's not super mathy, is equal to 1 minus the probability of 0 up to 2. My calculator can compute 0 up to 2. So that's going to be 1 minus the binomial CDF. And this is going to be 20.38 is still my P. And now I want to subtract 0 up to 2. So I'm going to let x equal 2. Remembering that in the CDF, this means 0 up 2. Let's get this into our calculator. I'm going to start by typing in 1, which is the probability of anything, and I want to subtract the cases that I don't want. I'm going to go into distribution. Let's arrow up to that binomial CDF, that cumulative probability. Hit enter, and I want 20.38. Looks like I already changed my x to 2. Remember, with cumulative, this is 0 up to 2. So exactly what I don't want. Arrow down to paste, and I'm taking 1 minus what I don't want, and I get my probability of 99.4%. You got this. I've got more for you here.